black mice again.
I'll put it up like right up the
Right, and that could be the case. But what we see here is that most of our population has brown fur. And so this is something we can use to find out more about our population if we want to look at what traits they have. But our graph might not always look like this. So what I want you guys to think about next is, what if the selective pressures in the environment push them and most of the population had black fur? What would that graph look like? So we still have a few with white fur, we have a few with brown fur, but what if most of them started to have black fur? All right, go ahead and hold up your graphs. What do we have? Okay, so I'm seeing some good ideas here. Basically, what's going to happen, our whole graph is going to shift to the right. We're still going to get this curve. It's just going to shift over to the right. We're going to see something that, we've got a few white, but not many. And then we're going to shoot up here, and then it would go back down afterwards. We have one more type of graph here that we use to show traits in a population. What if it was beneficial to have white fur, it was beneficial to have black fur, but we didn't really have many with brown fur? What would our graph look like then? So most of our mice here have black fur or white fur. They've got both. But we don't have many with brown fur. That's perfect. Awesome. Awesome. That's right on track. Yeah, for your ground where most of them have white fur or black fur. Yep. Exactly. Okay, everyone hold up your graphs. Let's take a look. Right, all of you gave me a graph that looks really in the middle, right? And so that is going to tell us more about that trait. We call that disruptive selection. And I've got these graphs pulled up here. So if you look at the board, this would just be a normal distribution. If we have something called stabilizing selection, that means whatever's in the middle is selected foremost. So our mice with brown fur are going to be selected for. Mice with white fur or black fur are not going to do well. They're going to get picked off. They're going to get eaten. This is similar to what you guys did with the moth lab at the beginning of the year. Do you guys remember that? Yes, no, kind of, yeah, but this is similar to that. If we have something called directional selection, that's where one of the extremes is selected for. So either our mice with white fur or our mice with black fur, and our graph starts to move over to the side, because that's where our population is. Disruptive selection is where we have both of the extremes are chosen, but our middle group, not so much. They don't do well. So what I want you guys to do now is go ahead and use your computers, or just, if you can think of something, what is an example other than fur color of stabilizing selection?
Eye color.
Eye color? I don't think so. I think eye color, we would just get kind of a normal distribution, because you are going to do just as well, you're not going to get less food or something like that if you have a different eye color, right? You're going to perform just as well. Is there any other ideas? What are we going to see with stabilizing selection? And you can use your computers. Look something up. Yeah? Yeah, so certainly. There could be some animals where it's really beneficial to be a medium size. Anything else? Yeah?
Is that the number of eggs a bird lays?
Absolutely, the number of eggs a bird lays. So if a bird lays too many eggs, they're not going to be able to feed their babies and they're all going to die, right? But if a bird lays only one egg, they're still not reproducing very well. So you got to have that perfect number. What about humans? Is there anything in humans you can think of where we see that the medium trait is the best? What about birth weight? So when human babies are born, if you are really big, it's going to be a difficult labor for the mom, and you may not survive. If you are really small, you also may not survive because you're not developed enough. So we see this type of graph when we're looking at human birth weight, because we want that medium weight here, because that's how you're going to survive best. What about directional selection? Can you guys think of an animal or a trait within an animal where directional selection is what we see in the population? Yeah?
Like the lizard has like a long tail, and I think that it's like a snake.
If they what?
Whether the lizard has like a long tail, but I think it's like a snake.
Okay, certainly. So some animals, if they have she said if a lizard has a long tail, it could look more like a snake unless predators are going to want to eat it. That could absolutely happen. Is there anything else? Anyone else have an idea? What about giraffes? What was that? How tall they are? Absolutely. So why do giraffes have long necks? That's actually not true. So that's a common myth that giraffes have long necks because they're going to reach the top of trees. People have done studies on this. They don't actually eat the leaves from the top of the trees. They just, eat the leaves from the middle part of the tree. Giraffes actually have long necks because that's how they fight. When the males fight for a female, they hit each other with their necks. It's kind of insane, so you guys should go home and look up a video of this because it's crazy. They will hit each other and beat each other with their necks. And if you have a longer neck, you're going to be able to hit the other person harder. And so that's why giraffes have been selected to have long necks, because you're going to survive if you have a long neck. So that is an example of directional selection. What about disruptive selection? Can anyone think of an example of disruptive selection? Go ahead and look one up. Pull your mask up, please. Everyone should be on their computers now. Look up an example of disruptive selection. What did we find? Yeah?
Like some animals, I guess, like if a squirrel has like a shorter tail, be better for it to like run on the but if it has a long tail, be better for it to like move.
Okay.
So it's like the same thing.
Yeah?
Light colored oysters or
Right. So there's some environments where it's light and dark, but there's not much of a medium color. So if you're a light colored oyster, you're going to blend in like with the rocks. If you're a dark colored oyster, you may blend in with darker rocks. But there's not really anything of a medium color. And what was mentioned over there about squirrels, if you have a short tail, you're going to do really well on the ground. If you have a long tail, you're going to do really well in the trees. But there's no need for a medium tail, because then you're not going to do well in either. So it's beneficial to kind of pick where you're going to be and be really good at one of those. So those are examples of disruptional selection. So what I want you to do for your post today is just give me an example of each of these. So give me an example of stabilizing. You can't submit it? I'll fix that for you. But give me an example of stabilizing, give me an example of directional, and give me an example of disruptive. And so you are not going to need to know those vocab words for the test. But what I want you to be able to do is understand what those graphs look like, understand how to make the graphs, because it is relevant to population.